Okay, so yesterday we looked at this graph sort of at the end of class and said that we would pick up right here. So it is a position versus time graph. Quick review. What can I read directly off a position time graph? What does it show me without doing any calculating? No, I have to calculate to get speed. Julia? Yeah, I can get distance, the position of a moving object. It tells me where the object is, okay, at various points in time. That's what I can read directly off. Now, I can use that to calculate distance because I can add all the sections together. I can look at how far each section is and add them all up because distance is scalar. All right? I can also calculate displacement from this kind of graph by doing what? I subtract two things. John, what are they? Final position minus initial position. Okay, so remember, I can get distance, okay, by adding the sections. Okay, I can get displacement, okay, by going final position minus initial position. Okay, can I get velocity off of this graph? Yes, in two ways. What are they? If I'm just dealing with, let's say, this section D here, I can use slope. Okay, or if I'm talking about the whole trip, can I just use this formula we dealt with the other day? Okay, now the thing to watch for, guys, is sometimes on a quiz or on a unit exam, I will say specifically how I want you to calculate velocity, because there are obviously two ways to do it. All right, so you do need to read a question carefully on the test. Okay, for example, last year I did this and I put in the question in bold-faced, italicized, slightly larger font, using your best fit line, calculate the velocity of the object. All right, and then people just went v equals d over t. How many marks do you suppose they got out of 4 for that? 1. I got to give them, I mean, they were close most of the time on the answer, but remember we said that using v equals d over t, if we're talking about a whole bunch of points, might not be the most accurate way to do it. All right, if we had a best fit line, that could represent a better average. Everybody follow? Okay. All right. So let's look at these questions here. So question number 1 says, what's the truck's position at each of the following times? Is that one of those things I can just read off the graph? Yes, it is. All right, so at time 10 seconds, so I go here to 10 seconds. Position is 150 meters forward. Okay, everybody all right with that? Okay, at 15 seconds, position is 150 meters forward. Okay, at time 30 seconds, position is 100 meters forward. Okay, and at 45 seconds, okay, we're looking at 350 meters forward. And at 50 seconds, we're looking at 400 meters forward. Pretty good with that one. Okay, remember, it's a position versus time graph. If I'm asked for position, I can just read that. I don't have to do anything. All right. Okay, for number 2, what's the truck's velocity in each of the lettered intervals? All right, so now, okay, we have to actually do a little bit of calculating. So velocity is either the slope of the line or v equals d over t. Now, for a single line, those are actually the same thing. All right, if I don't have points here that this is a best fit line of, going v equals d over t is actually finding the slope of this line. Would you agree? Okay. All right, so I've got this end point here, okay, and this point here. I'm going to use those as my grid intersections because they're the only two on that section of line. Okay, and so I will have 10 minus 0 and 150 minus 0. So 150 over 10 is 1.5, right? Okay, so for this section here, I'm essentially just going, sorry, 15. What am I saying? Yeah. Or 10 is 15. 15 meters per second. And we can say forward or positive or whatever. Okay, we do have to give a direction on that because, what did they ask for? Velocity. Okay. What's the truck's velocity in B? 0. How do we know that? It's what? The slope is 0. It didn't move, right? At the beginning of B, it's at position 150 meters. At the end of B, it's still there. If you didn't go anywhere, you don't have any velocity. Agreed? All right, so that's kind of an easier one. Now, for C, C is the only part of this graph where the object is moving backwards. All right, here's why. If I'm going to calculate the velocity here, my final position is 100. My initial position is 150. So when I do this, PF minus PI to get D, all right, it's going to be 100 minus 150 over, and that's a 10-second interval. Okay, that gives me negative 50 meters over 10 seconds. So my velocity is negative 5 meters per second. Okay. Is it okay to have a negative slope? Yep. All right. In part D, same idea here. Okay, we'll have 300 minus 100. So our displacement in part D is 200 meters over 10 seconds. So our velocity is 20 meters per second, or positive 20 meters per second. And then for E, we go up 100 meters. 400 minus 300 over 10. 100 over 10 is 10, positive 10 meters per second. MJ? For D? Because that's the final, that's the initial position. Right? It was at 100 meters at the start of D, and it ended D at 300 meters. Yeah? All right, questions on number 2? All right. For number 3, what is the truck's speed in each interval? All right, are all these intervals straight lines? Okay, so is the magnitude of the velocity going to be the same? Okay, since speed is scalar, all I have to do is take what off of all of those numbers? The direction. Okay, this thing went from 100 to, or from 0 to 150. That's 150 meters. I just don't say which way it is. It's just 150 meters in 10 seconds. Everybody follow me there? So it's, the speed is 15 meters per second. I just don't put the positive on. All right. The only one that really changes anything for is C. Instead of being negative 5 meters per second, now it's just 5 meters per second. All right. Okay, what's the speed of the truck over the whole trip? Okay, this trip has multiple sections. If I'm going to find the average speed, what 2 things do I need? Total distance and total time. The total time is 50 seconds. Okay, I can read that directly off the graph. But I can't read the total distance directly. I have to calculate it by doing what with all the sections? Adding them up. All right, so this section here is 150 meters. This section is 0. This section is 50 meters. This section is 200 meters. Okay, and this section is 100 meters. All right, so we'll have 200, 400, 500 meters in 50 seconds. The average speed is 10 meters per second. Okay, is any of that math really difficult? Right? Again, the math, like we said yesterday, is easy. Right? It's a matter of remembering or being able to figure out how to get to the math. And that's always the stumbling block in physics. Okay? A lot of people who are good at physics are like me. They suck at math. Right? I am awful at math. I struggled with math my whole life, still do. Okay? But I can do physics because I can see things. Okay? I can get to the math, which hopefully is easy. Okay? If it's not easy math, then I'm screwed. All right? But honestly, guys, I have people come into Physics 20 and they just think, well, this course is going to be so easy for me because I got 95 in math. They are often the people who struggle with physics the most because they're so focused on the math that they can't get to it. They can't see the stuff that's going on in the graph. They can't visualize it. Okay, and that's kind of the stumbling block there. So don't get focused on the math. The math is the easy part, believe it or not. Okay, it's the seeing what's going on part that's tricky. All right, any questions on the rest of that graph there? All right, as I said yesterday, I'm going to give you your formula sheets that you're going to need for the rest of this unit. Treat it better than you treated your periodic tables in Unit 1. It is your lifeline for the rest of this unit. You will need it pretty much every day. If you got one of those plastic transparent page protectors, it might not be a bad idea to slip it in there so it doesn't get ripped and torn and whatever else. Okay. At the same time, I'm going to give you the worksheet we're going to be working on today, which is basically like this. It's going to have a bunch of different kinds of graphs, and you'll be asked to calculate certain things. I'd imagine we're probably going to be going through a lot of those as a class, and that's fine. That was the plan for today anyway. Okay, so I'll stand over here, guys. When I call your names, you can come up and grab those. Just want to quickly look at 4 here because we got a few questions coming up, mostly about the acceleration thing here. All right, so it says find the acceleration between 12 and 14 seconds. Now, yesterday we said briefly that acceleration is the rate at which you change your velocity. All right, well, if this is showing velocity on the y-axis and time on the x-axis, rate of change would be velocity divided by time. In other words, it's the what of these lines? It's the slope. Okay? The formula that you have on the formula sheet you got today shows that acceleration equals Vf minus Vi over t. All right? Well, that's essentially finding the slope of a line on this graph. Would you agree? Okay? So for example here, between 12 and 14 seconds, so if I start at 12 seconds, that's right here. Okay? 14 seconds is right here. All right, my final velocity at 14 seconds is -6. Okay, minus 2. All right, over 2 seconds. Well, is that rise over run? It is, right? That's where this formula comes from. This is the slope formula. Okay, from a velocity versus time graph, but it works to find acceleration because it'll give me the rate of change of velocity, which is going to be -8 meters per second over 2 seconds. Sorry, and so that's going to be -4 meters per second Okay, so that sort of makes sense. All we're doing is really calculating the slope of that line. Right? We'll be talking about this formula, okay, next week. Right? But for right now, that's essentially what you're doing. If you calculate the slope of a line on a velocity versus time graph, you'll have the acceleration. Now, one of the other parts here says, what's the average acceleration between 14 and 20 seconds? Well, it's the same idea. At 20 seconds, the speed is 0. At 14 seconds, it's -6. 0 minus -6 is +6. Minus -6 is like adding, right? So minus -6 is 6 meters per second over 6 seconds gives you +1 meter per second squared. Or meter per second per second. We often abbreviate meters per second as meters per second squared. Okay. All right. Does that make sense on how to do the acceleration part? Okay. What about the rest of it? What about total displacement? How do we get that off of this graph? Yeah, I do. I know exactly what you're saying. So you're saying find all the shapes, find their areas. Okay, and so yeah, we do want to do that. Okay, that's supposed to be a triangle there. And yeah, if we find all their areas, yes, we can subtract the ones that are beneath the line. Okay. So yeah, you got to do a little shape drawing. That's fine. Okay, we draw all those shapes. We calculate all their areas. The big thing is you can either subtract all of these ones down here from this, or you can make these negative and add them all up. Either way, I mean, it's the same thing mathematically. All right, does everyone follow me there? This one's tricky because there's lots of different shapes, right? I mean, they're all triangles and rectangles. That's what you want to get it to, unless you know how to calculate the surface area of irregular polygons. I don't remember how to do that. So I just make everything a triangle or rectangle. It hasn't failed me yet. Okay, and I've been teaching physics as long as you guys have been alive. It hasn't failed me yet. Okay? Alright. So problems on that one at all, other than that? Okay, don't be afraid to ask, guys, if you got questions. Okay, so for 4b, okay, I want to find the total displacement, so I have to find area underneath the line. All right, now, why does area under the line give me displacement? Well, you got to look at the units that you're going to get as a result of that. What are the units on the y-axis? Velocity. So they're meters per second, right? Okay, what are the units on the x-axis? Time, in seconds. All right, when I multiply meters per second by seconds, what am I left with? Meters. All right, that's the units for displacement, right? Okay, that's kind of that analysis. We don't just want to memorize. Okay, we want to look at this and go, oh, well, meters measures displacement. That's what I'm asked for. I got to multiply together. If you're on a graph and you got to multiply two things together to get the value you want, you're calculating area. Okay, so here's what I have to do. I've got to make all my shapes, which I unfortunately erased just a second ago. Okay, and then I could. I just like right angle triangles. I'm one of those weird people that has just a certain way of doing things. All right. So we've got here, okay, all the shapes we have to find the areas of. Okay, and as MJ pointed out, we could do this first one here just as a triangle if we wanted to. Okay, and its length would be its base would be 1, 2, 3, 4 seconds. Everybody all right with that? And its height is going to be -3. All right, so -3 times 4 is 12, over 2 is 6. All right, so this one here is 6 meters, -6 meters, right, because it's below the x-axis. All right, then I've got this little triangle here that has a base of 1 second and a height of 2 meters per second, so its area is 1. Everybody follow me there? Base times height over 2. Yeah. Okay, and here we've got a height of 2 seconds, but a base of only half a second. Right, so 1/2 times a height of 2 is 1, divided by 2 is 0.5. Okay. I'm going to. I was in a triangle frame of mind. Okay. All right, so for this rectangle here, we've got 1, 2, 3, 4, 5 as the base, okay, and a height of 2. So the triangle is, or the rectangle, sorry, is 10 meters. All right, and then we've got all of these down here. Okay, so we can do this triangle, which is 1.5 by -6. So that's 9 over 2. This is 4.5. -4.5. Okay, this triangle here is 4 high by 2 wide. So it's going to be -4 meters. Okay, this rectangle here is 1, 2, 3, 4 long by -2 high, so that's going to be -8. And then this one here, this triangle is 1 long by 2 high, so it's going to be -1. Everybody with me so far? Yes? Okay, so all we did was base times height and base times height over 2, got all the areas on this graph. Okay, so I've got, oh, sorry, did I forget a triangle? No, I didn't. Okay, 6, okay, we got 6 meters, 6, sorry, -6. -6 plus 1 is -5, plus 10 is +5, okay, +5.5. All right, now we're down to -1, sorry, +1, -3, -11, -12. Okay, -12 meters. Right? Would you ever be asked to do one that involved on a unit exam? Never. Right? I would give you one that had way less shapes to calculate if I was going to ask you to do that, and I will. Oh, was that out loud? Okay, but it will not have as many triangles and rectangles. Probably like 1 triangle and 1 rectangle or something like that, just so you can show me you know how to do it, not how fast you can do it. Okay, any other ones? Okay. What do you do for, sorry, it doesn't ask for the total distance, does it? Okay. So now, how do you get average velocity? What did you just calculate? Displacement. Do you know how long the whole trip took? Can you find velocity? Okay, that the easiest way? It's the only way. Okay, if you're going to find average velocity off of a velocity versus time graph, you're going to have to find the displacement and the time and go total displacement over total time. Okay, listen up here for a sec, guys. On number 4 and on number 5, a lot of people are coming and asking me the same thing, okay? Because at the bottom there for part E in number 4, it asks, how do you calculate the average speed? What's the formula for average speed? What two things do you need? Total distance and total time. We just did all these area calculations and added them all together, and we got what? We got displacement, because we made some of them negative. Can distance be negative? No. So what do you do with all those displacements? Make them all positive, add them up, you got total distance. All right? Because remember, you just calculated it section by section, right? Well, section by section, displacement and distance are equal in magnitude. Okay? They're the same size, just sometimes displacement has a different direction. So just take the directions all off and add them up. And then you got distance. Okay? You got a scalar quantity then because you didn't pay attention to direction. Everyone follow? And you do the same thing on this one. All right? If you want to get the units for distance or displacement, meters, you have to find the area under the line. Once you've found that, then you treat it either as vector or scalar depending on the situation. MJ? Let's say no.